Hello everyone, and welcome to the System Enterprise Development course. And today we will talk about lifecycle models. First of all, what is it and what we need to know about it? Why? Lifecycle models it's some methodologies which help to people to work together. Some special rules which way work, and these rules helps people to interact between each other. What these lifecycle models determine? So there exist some kinds of different development lifecycle models, and each of this model describe some economics questions of project, something about risk management, what's happen with risks, and something about some timing and so kind of expenses risks, also about maintainability, something about architecture, what we will do with some errors, which of course will happen during our projects, and also what we will do with how we will understand that project is completed, how we will estimate this. So there exist a bunch of these models. Some of these very famous, some is less famous. So let's talk about most famous, most general lifecycle models. Also, here's the link of course on Udacity. You can visit this course, and there is lots of bunch of this kind of ugly pictures in this course. So if you're interested in, you can visit this page. What again lifecycle models describe? Lifecycle models describe which steps we will have during our product development, our project development, how we will describe that this transaction is ended and this transaction is started, how we will, which rules we will use to let some specialists to go to another step. So, for example, we can say that to make these activities, you have to first of all finish this point and this and this and this, and so on. Or on this step, you have to do this bunch of activities. And if something is wrong, you have to tell this guy that you have to repair it or something about this. So most of these models can be divided on two big parts. It's agile based models, some kind of incremental models, and waterfall models, which have to be step by step. Also, third type is object-oriented model. This kind of special model, and probably I not able to tell you a lot about this kind of model, but it exists, and we will have some slides about it. So agile models, it's can be divided on this type of models, and actually it's very similar between each other, but it has some different points, some different stuff, and in my practice these points is very about people relations. So you can say that we will work by, for example, build and fix model, but if you don't understand exactly what people in your team are doing, it can can be not very straight. So first model, probably the one of the oldest lifecycle model, and it's popular and today because it have very strong advantages. Waterfall model. Waterfall model tell us that on each stage we have to divide our project on several steps. In the most abstract way, it can be these steps like analysis of requirements, analysis of some input data, what we have, what we want to do. After that, we make some work about design. So we trying to realize these requirements. After that, if our product needs to, and if our project is includes, we made implementation. So it looks like this type of division more common for software development product, which is have implementation stage. And after that, if implementation is successful, we making testing and do some final polishing of our product and maybe make some modifications. And what is most special in this model, that on each stage you cannot go back. So requirement analysis, if it's finished, we start design. If we forgot something, we cannot go back. We just go through all stages, and if we want to modify something, we have to talk about new project, like we will have new budget, new some timing requirements, and only in next time, not in this. This is so looks like we talked about some benefits and drawbacks. So once more time, this is sequential change of phases. Also, we have software quality assurance. If we talk about software development, and also we have some feedback on the earlier lifecycle phases. And what is the biggest benefit, and why this model is still very popular? It's very low cost reduction. So, oh, do you? This model is the less expensive because we have the plan, and if something go wrong, we just go through it. What I mean about what can be go wrong, if we doesn't make enough requirements, we just have to make our processes on the each phase in such way like it doesn't have to make failed of all our project. So it's difficult, but if we able to do it, we get very big cost reduction during our project. And also another one benefit which is connected with cost reduction is that we have the constant final point in time. So we can define in the beginning when our project will finish, because we know everything about each phase just in the beginning. Of course, we can make some correction, and we can make some plus minus of week of time, but it have to be defined in the beginning. And of course, what drawbacks in this model? the end client will got and will see and be able to touch to test final product only in the end. So until the end, client doesn't take some action in this development, so he just waiting, and in the end he will get what he want. And if not, we in trouble. And this is one thing what we have to think about when we use this model. So we have to collect requirements in the very detailed way. So what also this model asks from us? Clear project discipline. So for each phase we have to write what we're doing on this phase, when it started, when it's finished, and what we have to do. Also we use documents in this model. This is one of the main points. So we have to define which documents on each phase we will make, which documents are input and which on output in each phase. Also, the software may not meet the customer's requirements. This is a problem situation which we have to think about, that our final product may not meet the customer requirements, so we have to make some special agreements who will be responsible if this situation will appear. And changes become complicated. So on each stage, when we finished, the results of the stage are frozen. So we cannot go back and to make some repairs. So we go through each phase and no go back. And as conclusion, this model doesn't include iterations and evolution. So this is waterfall. And as different way, this is kind of incremental models. Now there is a bunch of very similar incremental models. Agile is one of the most famous for today. This is kind of incremental based models. So what this lifecycle model asks us to do? We divide our project on some kinds of increment, and for each increment we define what we will do in this increment, what in the second, and so on. On the each increment we can define some finished iteration, and each of this iteration include full steps like analysis, after the design, after that implementation, and design again. So each iteration gets some bunch of kind of our product, and during implementation we got some feedbacks from our client, from our customers, and we can make some kind of new modification. Here is code design. Also here is shown that these two iterations can be made simultaneously, so during increment looks like we can make this some kind of changing in the simultaneous way. So what benefits we will get in this situation? The earliest return of investments. So we on the early time we get some feedback from our customer, from our who order our product, and it facilitates the maintainability. So it's easier to implement our product because we more frequent ask our customer about what he needs. And of course, disadvantages, it's require open architecture, and we can get a build and fix situation. Open architecture, it means that we have to create this kind of architecture which will let us to implement new features inside our product. So on the early stage, we have to make very spatial architecture of our product, which will let us to make some modification, but at the same time will stay the same during all the project. This is not easy, but if we will be successful in this, we will successfully use this model. And build and fix situation when we make some new features, adding some new functionalities, but after that we get in trouble, and on the next iteration we just spend all our time for fixing these new features because we got some problems which connected with these new features. And it can make situation when we make new increments just to fix old problems and not going forward. Also some description of this model. So we have to decompose development of our product in the sequential releases. It's not possible for all projects, but for software projects, this is mostly common. Also, we have to operational product at every development. So yes, we got some kind of product which we can test, which we can see at, which we can show to our customer, and this is benefit of this lifecycle model. Flexible introduction of the new functionality. If we create so-called open architecture, it's flexible introduction. If not, so. And easy maintenance due straightforward expanding. So yes, on each stage, if we will not get problem, we just easily maintenance new features. So, and another kind of incremental model called rapid prototyping model. So this is not famous, and I will not see lots of information about this model in the internet, but let's talk about just for example. So this kind of model is about, as you can see, about prototyping. So we make some prototypes, and which have very limited functionality, but at the same time we can show these prototypes to our client, and if our client just has not technical knowledge, he can see our product and to generate some additional requirements. And based on these requirements, we can make analysis and just edit our specifications and make our product more useful. So here's an image example of such case of using this prototyping model when we make some application, and here's application is not ready. We just make some images on the paper and show which interfaces we have, which screens we have with each button, and the customer can tell us so is it what he wanted or not. So on this example, here is looks like some food ordering application when we can choose type of restaurant, Chinese food, Japanese, American, and in each set we can choose which restaurant we want to use, and after that probably generate order some special kinds of food, some meals. Some types of rapid prototyping. So as in Waterfall, as in Incremental, we first of all analyze and generate and collect some product requirements and making requirement analysis. After that, when requirements are collected, we create first prototype and show it to client. And after that, he talks to developer some his feedback. We collect this feedback. Also, we just transfer this feedback to the manager. He is looking for this feedback. He's looking for project budget, and he probably talk with clients. So, okay, if you want this additional, you have to pay some additional or something, or we will change the finish of project line. So some kind of discussion. Okay, after that, again, it's returned to the developer. He makes he realizing some requirements, and again we get second prototype. If it's successful, it go to implementation. If not, we can return it to manager again and repeat this iteration. Okay, if everything is okay, we implement this product, we make some testing, technical testing, integration testing. After that, manager looking for our product and just making some his activities. And after that, we show it finally to the client. And if he accept our work, this is acceptance is finished and project is finished. If not, it can be returned to the requirement analysis stage, and this iteration will repeat again and again. So what benefits we get in this type of situation? So as you see, we collect customer requirements. So if customer doesn't have some technical knowledge, he can work with us. He can just tell his requirements in the language which he like, not in the technical terms. But what is drawbacks of this situation? That prototype can be different with a finished system, because this is very common that prototypes may be with different tools, different libraries, and of course it can be little bit differ with the final system, and sometimes difference is huge. Okay, next model is a spiral model. This model looks like spiral, and we have these stages. So first, as in the previous models, we have requirement management. So we collect some requirements. After that, we analyze these requirements, and this stage called in this model is risks. So yes, here is definition stage. After that, assess alternatives. So we just analyze and compare some alternative ways. After that, actually developing on the product, and the final, this is planning of the next cycle if it's needed. If not, here is just finalization. So requirement management, after that risk analysis, after that we can make some alternative analysis, and after that we just choose one of these alternative and work with this. So we making, if it's on the early stages of the project, we make some concepts, and after that we making some plan how we will realize it. After that we will review and accept this plan, and if everything is okay, we again looking for risks, so which risks we can have during this development implementation. Maybe again we can offer some alternative ways, and after that actual product design, and this can be different kind of detailization. After that we again making some planning. After that we reviewing what we got, and if we want to add some new stuff, we again analyze how it will connected with new risk what we will got, and after that we make new more detailization, and so on. By the spiral, we're going through these 4 steps until we not finished our project. So on the more and more far from the center, you can see that on the design stage we make the more and more detailed design operation. So if on the first steps is just concept visions, on the final this stage include detailed design, detailed code, unit testing, integration testing, and asset testing. So which features of this model? So as any incremental model, this model is offered to us that we have so advantages application to the entire cycle. So we have all advantages of the iterational model. At the same time, we have some kinds of waterfall model because on the because we have some analysis of the risk, and also we have some analysis of the output from the previous stage. So if this is not fine, we can just work again, but not go forward. And also we have risk stage. If risks not satisfied, so we can just stop this way of concept. And also this model offer to use several prototyping, so we have we can make some kind of batch more than one prototype. Also intensive interaction between lifecycle phases, so each phase is going one by one. Some phases can interlap, but not too much. Object-oriented design and object-oriented analysis. So these phases are included. Probably it have some special requirements, but here is we talk just about it. It exists, and backtrack to earlier phases is possible. I think it means that in the beginning we can inside one phase we can start it from the beginning. So backtrack to earlier phases is possible. One of the less famous model called object-oriented model. It includes these steps like first as requirements. After that, object-oriented analysis. So we analyze with object-oriented tools. After that, we use object-oriented design, implementation, integration, and operation. After that, we can finish or continue through the development. So the most difference from the other models, which is in that we use object-oriented approach. So our product is looks like an object with some special features, and we can divide it on the parts, which one of them is have some features. So it's a kind of special model which not useful for every project, but which benefits provide interaction and parallelism between the phases. So as you can see, some phases are overlap between each other, so we can finish some design, and after that this phase is not finished, but we started implementation. So this model doesn't ask us to make some baselines, so the phases can be overlapped. And of course, disadvantage that it can make situation tab with code a bit, test a bit, and it's look like build and fix. So again, we can just stuck in the reparation of new features. New features will make new bugs, and we just fix these bugs and so on. What is the similarities of these lifecycle models? All of these models can here's about, of course, iteration models. All of these iteration models can make include all stages of this. Okay, here is not just iteration models. All these models include all stages of the software lifecycle, but in the waterfall you cannot go through. You cannot go back. In the iteration you can. All of these models involve several iterations of project development. Or inside just and in waterfall model, you can just inside requirement analysis make some refinement. So just general requirements, after that more detailed requirements, after that more and more detailed. And yes, we cannot go back when it's finished, but each of these phases has some iteration. Involves several iterations. Software lifecycle stage is clearly distinguishable except for all. So it's all this cycle is clear, and you can plan it. related to the design methodology and require higher organizational maturity. Like every of plan, it's of course require higher organizational maturity. So here is some advantages and disadvantages of each model. Here is kind of build and fix situation. Sometimes it have some advantages too, but in general this is not good situation. Waterfall clear, discipline and document driven. A disadvantage is that we can have some troubles with requirements. Rapid prototyping and incremental and all of other projects have advantages in we have more interaction with client, we able to collect more requirements and define it better, but we have problem with budget, with timing, like it's more difficult to say when this project will finish, when it will be done. So when you choose a software process model, you have to think about understanding of requirements, how well you understand the project, how well you understand the final product. Expected lifetime, so how big this project is going to be, how long it will take to develop and how long it will take to use it by customer. Also, of course, you have to think about risk. You have to think about schedule. So will your specialist have enough time? Because it's usual situation when specialists work simultaneously on the different projects. So you have to organize your project with it. Interaction with customers, and of course you have to think about expertise and about your qualification of your specialist. And here's I made one diagram which is like conclusion, can help you to determine which development model better to use for your project. So first of all, you have to understand project, definitely. So understand requirements. If you understand this very well, if you made such project many times, waterfall-based project can be a good option. If you don't understand, if it's something new, something maybe scientific based, something which no one else made before, or this is maybe just new for you, for your specialist, and you will get a big risk, you probably have to think about incremental based approach. Also, another question is what is project size, what is team size? If you have a big project and big size, like more than 100 specialists, you have to think about waterfall, because organize of hundreds of specialists is easier used by waterfall based models. But if your team is pretty small, in the ideally it's 5, like 8 or 10 specialists, the incremental based approach can be good for you. Another question is how expensive is production. So will you work with the real physics and materials? If it's not software product, but if it's hardware product, it can be very expensive to go back in the middle of the project and on the final stages, because the hardware is you will not able to change something. So if this is common for your project, probably waterfall-based project is the option in this situation. And also let's talk about some kind of mistakes. If I told in the beginning, the lifecycle model selection, development model selection is the lots of about the people, about interconnection between these people. So here are some the most common mistakes which happen on the project. So first is heroic, when some people have probably high qualification, or they just want to make more for your project, but we have only 24 hours in our time, and we have only like kind of ideally 8 hours of work per day, and yes, 5 days per week. So we have to limit the kind of task which every person in our project are going to do, and also in situation where some of specialists want to take more, we have to think about risk that we get risk that he will not able to finish in time, or he will get some troubles with health, and again we will got some risk on our project. So we have to limit the task, limit the work time of our specialists, either if they want to make more. Work environment. So yes, we have to think about some environment, some infrastructure which used by our specialists. So we have to think about computers, furniture, and also some so everything which able to create some risk for our project. And if we will not think about it, we can see some risk which can make a problems. And also people management, it's mostly called like soft skills. Also I call it people relation. So you have to choose some instruments, approaches which help to people to better interconnect with each other. Maybe some situation, maybe just create some time for them or places. So it's all connected and it's all special for every situation. Another mistakes is scheduling issues, like if the specialist work in the different kind of project. So if specialist work in the more than one project at the same time, we have to organize his schedule with probably different managers, different project managers, and this is important questions, and we have to solve it. Planning. This is about planning of project. So we have to spend some time for this, and doesn't make it bad. And also we have to think about failures. It will appear 100% on every project, and we have to think about the situation and understand what we will do, how we will prevent these failures, and what we will do if this failure happen. Here is some like gold plating, we have something that cannot change. So everything is changeable, and we have to just understand why we're making some changes and what we will get if we will change it. Feature creep, like when we add more and more features, of course we have to think about every feature and understand does it need it or not. Research, not development, like some situations when we're making some research, getting some results, but these results not delivered in the development stage. So ideally the research have to go with connection with development. So it not have to be one after research have not be the different phase with development. It have to be made simultaneously. Silver bullet syndrome, this is kind of when some specialists are familiar with some instruments and they like it and it work, but and they use these instruments in every situation. Again, we have to think carefully how is it suitable, how these instruments suit in our situation. Switching tools in this problem, when we started using some kind of tools and in the middle of the project, middle of the some kind of phase, we start to switch tools and spending lots of time to switch tool and mostly this is the problem that we have not planned a lot, have not researched enough with about the using of the special instruments. And no version control, so of course version control is good for a project and you have to use it. So here is some references, and mostly this is all what I wanted to say about lifecycle models.